and hide the meeting. Okay. Officially, good afternoon, everyone. I hope you're doing great. Please just open your book, page 25. And as you remember, we said that this chapter is all about going from A to Z, one simple model. And for the sake of just opening the gates to deep learning, we use a Hello World project, and that Hello World project is nothing but MNIST. There are lots of things that we might not understand fully, but guys, there are like the gaps that we are gonna complete it down the road. So don't worry about it if you just see some of the concepts are not very much clear. If you see, it says that let's look at the concrete example, and that is MNIST, which is a Hello World thing. And where is Pawan? Look at this one. Pawan, 60,000 handwritten digits, 60,000 samples that we are going to train our classifier. Guys, look at this one. What is the goal of having classifier? Tell me. Anyone? William, what is the goal of classifier? To classify. What is the goal of classifier? To classify, to say if it is cat or dog, right? To train as William address. And after training, this guy is going to be able to just classify which picture is cat's picture and which picture is dog's picture, right? To classify. Okay. You can think of MNIST as a hello world, as we said. And for those people who haven't participated in the quiz, I very much emphasize on this paragraph. I said in machine learning, a category in a classification problem is called what? Class. We have different classes. We have class of, what are the classes in MNIST? Class of 0, class of 1, class of 2, all the way to 9. Guys, you follow? What are the classes? Nash, 0, 1, all the way to 9. These are the classes. But what do we call the class for one specific sample? Pardon me? I'm sorry? Nash, right? Exactly. As Nash mentioned in data points are called samples. So every row, data points means rows, samples. So rows are samples. And the class associated with a specific sample, I read it again, a class which associated with a specific sample is called label. What is the other word for it? What is the other word for it? Category is the same as class. But for this one, we can say why, right? The other thing is dependent variable. The other thing is ground truth. All of them, if you see in any place, they are all about labels, right? Okay, let's see. This is something that I talked in the previous class, and not this one. I have a good news that I'm going to share with you, but do not share it with people who come later. Okay, deal? We are going to have our midterm on week 7. But that's not a good news part. The good news is it's going to be online. What is the difference? Well, you're going to be more relaxed. And I trust that you're not going to use ChatGPT. Pardon? Me too. Okay. Look, we had fun time in the profs meeting talking about ChatGPT and anti-ChatGPT strategies that we use. Most of them are failed. Anyway, so look at this one. We should accept it, right? One of the profs said that embrace it, just accept it. Time has changed. Okay. So look at this one, guys. We start from the most left side. We have a handwritten digit. To show you that, I used whiteboard, but because I record this session, the best is to use Paint. Look, if I have that handwritten digit 6, what's going to happen? Guys, I receive non-stop questions that shows we need to intensify this part. Still, we have concerns about it. Let me just, this is a very nice, but a little whiter. Okay. Okay. Tell me, what are the number of pixels that we have here? 28 by 28, right? That is MNIST. We are going to give this, imagine that we give it to one of those shredder machines, and it's going to make them like these kind of things. Am I right? And 28 by 28 is equal to what? Rachel? Don't tell him, okay? So what is 28 by 28? Yes, exactly. 784. That's why you see in this picture 784. Guys, what are these lines? Bruno? Oh, sorry, Nicholas. What are these lines? Oh, these are neurons. You're right. But the connections between neurons, yes? Yes, weights. And they, as they say, they are fully connected or densely connected. We are going to see all these terms. Again, the idea is intensifying what we already know. Like we have weight 0, weight 1, weight 2, and weight 3, right? Here. And we have the same thing for those. Anyway, what do we have on top of each of these guys? Each of these hidden layers? Anyone? Who said that? Yep. Nash plus and Mikita also. And we go all the way to the output layer that we have. In this example, imagine that it is cat or dog, for example, right? Then we have just, or cat or not cat kind of thing, right? So are we going to give the best answers for the first picture that we are going to see? Why? People say no, but why? What are random things? Weights are randoms and biases are zeros. So the calculations is totally random. So if you have 10 possible options as your outputs, what could be the chance of each of them, regardless of if it is 1 or 2 or what? What is the chance that it says, okay, it is 1, it is 2? What's the chance of each of those? 10%, right? Equally, because I don't measure anything yet. I just say, okay, these are the weights and these are the weights. Guys, can you follow everything so far? And Kumar, look at this one. The first picture that I show you, that's the first picture. Imagine that 10 digits. And that is what? Number 6. Okay, for example. And we are going to say it is 7. Are we going to jump into say, hey, it is not 7, it is 6? Are you going to do it right away? What are you going to do? Are you going to wait till 60,000 goes and then say, you know what? Now I realize that it was not 7. Hey, too late. So what could be the compromise? What could be the middle ground for it? Any word? I changed my mind. The test will be in person, guys. Yes. No, I'm talking about the number of pictures that we are gonna see, and then we are gonna say, hey, you know what? Let's fix it after these numbers. Yes. Nicholas. Excellent. It's a batch. Okay. Next. What is the normal number for batch? 128, 265, 512. It really depends. But normally we play around with those numbers, right? So long story short, you show first digit, second, third, all the way to 128 picture, right? And then you say, now calculate how far from the perfection you are, right? And that is what we calculate as, what's it? What do we call that error? Loss score, okay? We call that loss score. Let me just show you something. What is the best? I expect now everybody can answer this question. This is a simple question, guys. Imagine that we have this and we have some random dots here and there. What is this type of problem? Imagine that price of the house and size of the house. What is this nature of? No. So this is the price. This is the size of the house. The bigger the size, the more expensive the house could be. What is the nature of this kind of thing? Guys, linear regression, right? So it's a linear regression. And we are going to say something like this line maybe is the best to get the answer. Look at this part. What is this size of the house? Here we have size of the house, right? What is this? What is this vector? What is this? That's the price. Lovely. Okay, so imagine for this one, I thought that I thought that if the size of the house is this amount, right? For instance, 600, if the apartment is 600 square feet, then the price of that would be, I don't know, 200K, right? But actually, I found it is 240, for example. Okay, it's fabricating numbers. So what is that difference? Tell me that what is that 40K, $40,000? That's the error, right? I expected that, so I made my money ready and I went to buy it, and now I see that the real price is 40K more than what I expected. So that is the error, and it has what? It has unit. It is $40,000. There is a unit for it, right? What if, for instance, for this house, actually it is bigger, 800 square feet, but the price is 160. What is this one? This is, I expected that, well, actually this one should be 240, while it is 160. So it is 80K cheaper than what I expected. What is that? 80 nothing or $80,000. We have a unit for it. Guys, hopefully you consider data science or related things into account. If that is the case, one of the questions that you may face is this one. If I want to see anybody knows about data science, I'm going to ask this question. What is the difference between accuracy and loss? What is the difference between accuracy and loss?
In the accuracy and in whatever the value is there.
Okay, what is this one? Is it accuracy or loss? Lovely. Loss has unit because you're talking about how far in terms of, for instance, it could be the weather prediction, degrees centigrade. So I predicted today is going to be -5. Now it is -1, for example. So 4 degree, guys, you have unit for it. The error has unit. Does that make sense, Bruno? Error has unit. Okay, if you want to write it somewhere, just this tiny, teeny sentence. But so error or loss has unit. But imagine that cat or dog, head or tail, I have 100 labels, but I could guess 85 out of 100 correctly. Could we say $85 or 85 degree or what? Is there any unit for it? We say 85% of the time our guesses were correct. So the accuracy has no units. It's about the percentage. They go through the same road. So if the accuracy is higher, the error would be lower. You know what I'm saying? So it's not like if the accuracy is higher, the error would be higher too, right? You expect that when you, and there is one beautiful thing about deep learning. You consider how you can fix your mistakes, but the result would be higher accuracy. If we just focus on how we can do better to fix our mistakes, we can have higher success in life. The same applies to deep learning. Just write it somewhere. The focus in deep learning is how we can fix the errors. Right? Now getting back to your question. So now we understood we are going to show how many pictures do we have for MNIST for training? 60,000. I'm going to show you 60,000 pictures, handwritten digits scanned, right? 28 by 28. So that 28 by 28 that's 28 by 28. We know that we cannot fit our machine using 28 by 28. We need to do something. What do we do to change the shape and shred it? This guy, I'm sorry. This guy is going to be the first kind of thing. And the next is going to be here, right? And that 28 by 28 goes all the way to 200, sorry, 700, my bad, 784 pixels, right? We are gonna just first do this. This is nothing but reshaping or flattening. We say both of them. Flattening means make it flat, one column, or the other word is reshaping. We say 28 by 28 is equal to 28 times 28, or 784, comma, 1, means 784 rows. Guys, everything is super clear so far? Yes or no? Or yes? Look at the next part. We give that to our neural network. I want to ask again, Pavan, the first picture, the second picture, the third picture. When are you going to say, stop, Reza, I want to calculate the error? After the first batch, which could be, for instance, 128, right? So I'm going to show you the pictures. And you say, okay, wait, after 128, I calculate my first delta. What is first delta? The difference between y you predicted, we call it y prime, and what is the actual label, which is y. We call this delta, or the loss that we have. Everything is perfect. So this is the first batch. Let's say batch number 0. We go to batch number 1. It's going to be from 129, or if you started from index 0 to 127, then it's going to be 128 all the way to 255. Does that make sense? The second batch. So it's going to be B1. You calculate delta for that. Then you go all the way to, I don't know, BN, the last batch that you finish. How many photos here? 60,000, right? We finished this. After finishing 60,000, what is the round? It's just the first round of showing the pictures, the first epoch. Forget about it. The first time that I finish demonstrating all the pictures to the system, and I finish 60,000 pictures, that's the first epoch. Very simple. Don't make it kind of complicated. Okay, count the number of people in the class. 1, 2, 3, 4, 5, 6. Finish epoch number 1. Count it again. Another epoch. Count it third time. Epoch number 3. You got it? You do repetitive job 3 times. But the good thing, why, Reza, you tease me? Why should I start something doing all over again? Look at this part. At the beginning, all these values were random numbers. So the result was awful. Huh? But when we go to the next epoch after 60,000, now start again. They are stateful, they're not stateless. So those weights and biases are always safe. Does that make sense? So we make it a bit better, a bit better, a bit better. We are gonna watch a video, but guys, it could be lots of factors that you cannot click to what the instructor says. The good thing is there are tons of resources. Go and watch them. For me, that happened. I audited one class, one course 2 times. He was the chair of the department, and I couldn't understand anything. Then one of those aha moments happened. After watching randomly, I started watching something belonged to Google TensorFlow videos. And I was like, wow, now it makes sense. But it was not because that TensorFlow was awesome, because I tried everything, but one of them just told me the way that I could understand. They're gonna find. Okay.
So there over there, right now we have 2 variables, so that has no relation to the epoch. So that entire thing is 1 round and that is an epoch.
I show you the first, I said round. Did I tell that a student ID name? I said just count the numbers. Show the pictures. Finished 60,000, 1 round, 1 epoch. That's it. Has nothing to do with the number of layers, nothing to do with the weights when we say. Okay.
With that person.
Yeah, just select 1. Okay, look at this one. We said all those things, but I want to ask you one thing, which is Control C. Go to the whiteboard. Control E. Okay. Guys, what is the texture of what we have on the left side? What is the material that we have here? What is it? Is it a digital number or just a sketch? Something handwritten digit. Which one? Prakash, what's it? Okay, so we have something like this, right? A sketch. What do we have on the right side? Huh? Tell me. Label. What is the texture of that label? Guys, what is the type of left side? You said image, picture, sketch. What is the texture? What is the material that we have on the right side? Pardon me? Printed? With just number 7. Number, integer. What do we have on this side? A cat, right? Let's say cat is 0, dog is 1. What can we have on the right side? Tell me. 0 and 1, just digits. Number, it could be binary. What I want to tell you is this fact. Guys, here we have picture, the other side we have a number. Is it a kind of linear, smooth, pain-free transition? Think about it. Is it possible that you say, okay, got this, A multiply X plus B, it's gonna give me this result? Yes or no? Is it linear, painless process? Perfect. I would love to see the formula that we create for that, and I'm going to give you the 100% And we are gonna both together win the Nobel Prize. It's gonna change the whole human story. You can talk to your neighbors. You can talk to the other neighbor. Hello. You mind if that- Okay, don't worry. I'm gonna stay after the class. If you go to the announcements, the full classes are already booked, booked, and you can find them in YouTube, including today. Okay. So Malik, what is your opinion? Is it a linear transition? Is it a linear transition from that to number 01, for instance? Guys, this side is a picture, pixels. It has nothing to do with just saying come to 1 or 0. It's not a linear, smooth transition. We need something. What is that something? What is the general formula that we use? I have to use here, sorry. What is the general formula that you use, guys? You told me already, these are, for instance, W0, W1, W2, all the way to Wn. Does that make sense? And also we have those 0 all the way to M. Sorry, it's M. Neurons. Can we simplify it and say we have a sigma of activations? I'm talking about these guys. Activation I and weight I from 0 all the way to M or N, whatever. I just simplify the formula. But this is A, I, W, I. We are going to say everything that is for just going to this, it's going to be added something here, which is what? Bias. Everything is clear so far? But we want to have non-linear relationship. For having non-linearity, oh, I could pronounce it, non-linearity, we need to have something stochastic in the middle. Okay? And that stochastic thing is nothing but ReLU, activation function. Guys, could you relate to that? No? Here we have something like picture, William. This is picture. This is the digits. There is no way that you can say AX plus B and you go and find the answer for the other side. You know, you need to inject non-linearity to the circuits that we have in the middle. for doing that, you need to say, okay, let's just turn off some of these switches. Let's intensify some of these, right? To make it non-linear, because it's not a linear transition. Just think about the theory and forget about how the math works. Whatever you learned so far, guys, the way that you look is different from the other section. It's like, this is the first time that you see this picture. Guys, talk about this to your friend and see what you understand, and then I'm gonna summarize and tell you. The input number of neurons or activations. A is the first one. Yes, A0, A1, A2, all the way to AM. And we have weights. And I just simplified it saying we are going to have AIWI multiplying all those weights and biases to just get this one, multiplying all those A's to weights to bring it there, right? Sorry? It's instead of this omega, this kind of a stochastic thing that we inject, random thing that we inject to turn on and off those things. Okay. Is everything fine? James, can you relate to this so far or no? Okay. What about calculating? Let's just ask you this one. Control C, it has less number of neurons. So look at this one. Okay, to calculate the value that we have in here, okay? What is this? Let's say A0, right? What is this one? A1. William, what is this one? A2, for example. In this two example, just let's have 3 elements, 0, 1, 2. Everything is fine? Okay. A0 multiply W0, that is this one. And then, guys, this one is W1. And this one is W2. Does that make sense? Can we say it is like A0 multiply W0 plus A1 W1 plus A2 W2? Is it okay? Yes? It is very simplified. How can you model it in, how can you say it in math? Sigma? I from what is the base for I? All the way, I equal to 2, but in general, let's say n, because we are not sure. For this two example, it is 2. You're right. Okay. Is everything now clearer? Right? And what are the things that we have here inside parentheses? Tell me. A, I, W, I. Nash, does that make sense? Huh? So we calculated, guys, this is all about this one. But still, we have to add something. By the way, it's the best approach that you use. For instance, take a snapshot or something. I record today's session and it's going to be uploaded to YouTube, just in case if you want to. Okay, what do we add to this column? Tell me. Son, what do we call the guy that we add to this column? Huh? Bias. So we are going to add bias to this equation, right? But what is the problem of this approach? It is super linear, right? It's like every day you go to work, you come home, Netflix, the next day, there is no surprise, there is no kind of challenge. Huh? Let's add some challenge into life. What is the challenge that we can add here, guys? Tell me. We are going to multiply everything into oh, now I like it. Now this is kind of complete. Let's multiply it by omega. And that is, it could be ReLU. It could be sigmoid. That's for the last. We are going to talk about this today. That's a good thing. Yeah. So it could be ReLU. The ReLU is just like this. If it is less than 0, then it is 0. If it is more than that, whatever x is, that's ReLU. And it could be sigmoid. What is sigmoid? It is something like this. Actually, that's my bad. Let me just clean that one. Sigmoid is here. But please accept the thing should be in, I don't know, for some reasons. Yeah, it is S, but the middle is going to be something. Okay. Why we have that factor? Because we want to make it non-linear, right? This is why we use this to make it non-linear. Okay, let's go a bit further towards, again, tell me one thing. I calculate and say that the output is y prime. What is this, Munira? It's our prediction. It's our y prime, right? What is the actual label, William? Y, right? We said it at the beginning of the session. So the actual target is y. What we predict is y prime. What is the difference between these two? Delta or loss, right? And does it have any unit? Delta, does it have any unit? Yes, it has. So delta or difference or loss has units. So you calculate that. Who is responsible to calculate loss? Who said it? Tell me, what is it?
Loss.
Yeah. As simple as that, Pawan. Yeah, loss function. Who's gonna use it? to correct, to change? Sorry,
Offline.
you're on a right track. Lovely. Yes, optimizer. An optimizer is going to change what? It's going to change these weights and biases, right? It's going to change these weights and biases. Do you remember the rope that I showed you in the previous session? And I said, it's going to start changing this and goes to this and goes to this. You're going to just change everything, right? You try to minimize the loss. Okay. And now we understood one thing and one fact, and that is because it's not a linear transition, we need to turn on, turn off these intermediate neurons by using ReLU or any activation function, sigmoid ReLU. Okay, by saying that now, this is something that in one of the classes, one of our team members said, Reza, give us a kind of drawn view of the things that we learned, right? And then everybody please run this line. Let's go to the first line. Run from Keras, data set import mnist, and then load the data. Whenever you are done, give me a signal, please. You already have the file, just bring it to Olaf, starts running. Done. Everyone, done? Jason? Yeah. Okay. So what is the next thing that we have? If you say train images, what does it mean when it says 60,028 by 28? 28 by 28 pixels times 28 pixels, but what is 60,000? Sorry? Samples. 60,000 samples. But don't worry, every session I give one bonus to one not correct answer, so that's the time. Rachel. Rachel, let me find you. Okay. Next. How about the color? Why don't we have any color channel here? Guys, they are not trick questions, very simple answers. Why don't we have, for instance, red, green, blue somewhere here? Why not need it? Well, actually, because it's grayscale, right, Stefan? Okay, so we don't have any color, so that is why we don't have any color code to say red, green, blue. It's like 3 plates. Huh? Look at the next one, please. How many labels do we have? Let's just run it together. We have, for 60,000 pictures, we have 60,000 labels, right? instead of len, let's use something else. Let's say train underscore labels dot shape. What's going to show? The same thing, 60,000. Huh? And it's going to tell us it's a vector, 60,000 numbers. For each picture, we have one label, right? Sanjay, is it correct? 100%? Right, Bala? I see just part of the image. Okay, let's go to the next part, labels. Now, let's see what are the labels that we have. Guys, please say train labels, and it's gonna show you for the first one, the label is 5. Can we suppose the picture for the first one should be handwritten digits like 5? Is it going to be something like this, for example? And that is why we have because we have a handwritten digit 5 here, then we are going to have number 5 as the output on the other side. Can we say that? Right? Let's see. If you left behind, what we are doing is on page 28, test labels, it shows, sorry, train labels. And then now check the test image shape, images shape, and then test labels. It's gonna show you something like this. 10,000, 28 by 28, and the length would be 10,000 as well. Okay, test labels, they start from 7 all the way to 6, that's number 10,000. Or the index, if it starts from 0, it's going to be 9,999. Whatever we did so far, if you like, spend a few seconds with your friend, discuss it. If not, you yourself just work on it individually. And after a few seconds, I'm going to continue just to make sure everybody knows what is happening. Nicholas, anything back? This one will be extended one. Okay. So, Malik, not Malik. But the good thing is you rarely unbundle computers. Yeah. Okay. So, are we done? Look, now is the time to go to Keras and let's import models and layers, guys, for any model that we want to create in deep learning. We need to import these two models and layers components. Why we need that? Because models here are like box of rules. I repeat it, models are like box of rules. And at the beginning, it's an empty box of rules. The next thing is layers. Guys, what are layers? It's not a trick question. Tell me, what are layers here? Anyone? We have inputs layer. We have outputs layer. And these intermediate layers, we call them hidden layers, right? So guys, is it shallow learning or deep learning? Who cares? Huh? Is it shallow learning or deep learning? We said if it is more than 2, definitely it is deep learning, right? So then getting back to this part, importing those things. What are the steps that we go through for to train our classifier? Let me read this one. It says that the workflow will be as follows. First, we'll feed the neural network of the training data, like train images and train labels. You remember that we had apple and orange example in the previous semester? We said that, okay, 150, 170, these are apples. Oh, sorry, these are oranges, bumpy. And then we said 130, 140, smooth, they're apples. Hey, computer, go and find relationship between those inputs and outputs and make a kind of regulation. So based on that, if I give you any new fruit on scene data, then you can judge if it is apple or orange, right? Exactly the same iteration happens here. First, we fit our model with training data and the watch, which contains training images and train labels. And then the network will then learn the associate images and labels. Finally, we'll ask the network to produce predictions for test images. Now I created the model and ready to accept a new fruit and say if it is apple or orange. Does that make sense? Yes, Pavan? I create my model and it is ready to predict a new fruit that I give. The same thing. So it's going to tell you, I think the label is this one. If it is correct, good job. If not, that would be the error, which we are going to, just try to fix it and getting better. So we imported models and layers. Please search what is models.sequential. Why we say network is equal to models.sequential. Yes?
To create the neural network.
Yes, but why sequential? Do we have anything else which is not sequential? Yeah. We have two types of models in deep learning. One of them is functional, the other one is sequential. Most of the time you see people use sequential, but because we could use the other form, we need to say which one we are going to use for our model. So sequential. What are these guys? Now we start to define, guys, can you tell me how many hidden layers do we have in this model? Anyone? Bonus mark. How many hidden layers do we have in this model? Considering both lines. Pardon me? Yes. Uh, that's correct, but for number of neurons. Yeah. Two, okay. Some people say two, right? The good thing in computer, you can just later say that 3, 0, 1, 2. Which, guys, totally we have 3 layers. The first one is what? 28 by 28. That's the input layer. The next layer is that 512, and the output is that 10. So technically, we have 1 hidden layer, which has 512 neurons. Does that make sense? Yeah, Jason? 100%? Okay, look at this one, guys. Now, the good thing is we have the hidden layer here. We have the input, we have the output. Definitely, we have to say what would be the output. What about the input? Is it necessary to say we have 28 by 28? Do you think so? Who said yes? Honestly, I don't want to say no to you, but it's not necessary. This is just for readability. If you don't say it, it's gonna calculate it by itself. Malik, what's your answer? Thank you very much. I appreciate it. Yeah, it's not necessary. It's just there to increase the readability. The good thing is it's like, what do we call this guy? Lego bricks that we put on top of each other. It is going to check the previous layer by itself. The numbers, it's going to adjust it automatically. Yes, question?
Then it have like the cat image.
Uh-huh.
Would 10 be 2?
Uh-huh. For no, this is for MNIST, handwritten digits. That could be 0 all the way to 9, 10 different. But if it was, it should be 2, and the activation should be sigmoid, not softmax. This architecture of the middle, this is just a toy example. You could have many other possibilities. You can just, I mean, use 10 layers, hidden layers. For each of them, you could have 10 different number of neurons and so on.
I had multiple hidden layers. Each of the lines had good shape.
Do you remember that in the previous semester, I showed you something and it had 4 different things. One of them was kind of circle kind of things. The other one had some dots here, some dots here. The other one was a kind of a spiral. The other one was just some different colors here, some different colors here, right? You remember that we played around with the number of neurons in the middle, number of layers. What I want to grab from this is there is no fixed answer to say, William, always you have to choose 512 neurons or 2 hidden layers. There is no perfect answer or the answer that works all the time. Right? Okay. Getting back to this part. What is softmax? Please search bonus mark. It's an activation technique, but what is it?
Also vector of real numbers with probability.
I heard one of the keywords that I wanted to hear. Probability. What kind of probability? Halal.
0 to 1.
Huh?
0 to 1.
0 to 1. Yes.
Probably with each possible outcome.
Lovely. Okay. We are gonna see that today in one example. Right, Malith? Right? We are gonna see the possibility. And what is that? Imagine that for this one, guys, at the beginning. This is number 6. At the beginning, or let me just bring this example. Control C. As I told you at the beginning, the chance of the first number, regardless of the number that you show here, okay? If you think you can just switch. The chance is gonna be 10%, it's gonna be 10%, it's gonna be 10%, it's gonna be 10% all the way to the end, at the beginning. But little by little, it's going to make it better. So number 3 would have something like, imagine that 72%. 2 is gonna have 5%. This one is going to be 1%, and so on. The overall is gonna be 100%. Technically, they are like 0.0, 0.0, or 0.72. The overall sum would be equal to 1. You are not interested when you give a picture to say that, you know what, Reza, I think that it's 72% 3 and 10% 1. And hey, come on, tell me if it is 3 or not. You know what I'm saying? You just want to have the output. The softmax responsibility is to pick the highest possible possibility here. Okay, does that make sense? Okay, so why for something more than 2 we use softmax? That's the best design for those kind of distributions. But what if we have cat or not cat? We have 2 just possibilities. We use sigmoid here. If it is more than a threshold, it goes to the category of, for instance, cat. If it is less than the threshold, we should go to the category of dog, for example. Does that make sense? So here we just say less than intersection, go to the dog category. Above it, go to the cat category. Right? Okay. Let's go to the next part. Those who answered the test MCQ quiz, they know the value of this one. The core building block of neural network is the layer. And the good thing is, if you check it with ChatGPT, it's going to tell you neuron. Yes. And I try my best to find all those things that the book said something, and ChatGPT gives wrong answer. So be prepared. Guys, instead of relying on ChatGPT, just read the book once. Okay. So the thing that make neural network is not neurons, is layers, because the concept of neuron is in other architecture. But layers is something that makes deep neural nets better. Okay, just write that somewhere. Yeah. What makes neural network, deep neural network, different from the other is the concept of layers. Look at this one. It says that the core building block of neural network is layers, and it works like a filter, and it's a kind of step-by-step distillation, progressive data distillation. You remember that I told you densely connected or fully connected? If you hear fully connected, densely connected, or full mesh, they all talk about one concept. What's it mean? Look at this one. Means from any one of these neurons, we are connected to every single neurons in the next layer. So it is fully connected. I think that the overall idea and the main focus of this session is this part that I mentioned. The transition from left side to right side is non-linear. And what helps us to have that non-linearity is nothing but this activation function, which is ReLU, for example. Okay, to make the network ready for training, we need to pick 3 more things as part of the, that is another question in our quiz. What are the things that we have in our, it says that to make the network ready for training, we need to have 3 phases. 1, loss function. The other one, optimizer. The other one, a metric to show the progress, right? A metric to monitor during the training and testing to show how good we are. Now we want to create our compiler. So we use optimizer. Ramsprop is one of them. Adam could be the other option. Loss is categorical cross entropy. The question is, what is categorical cross entropy? We are going to see that. And metrics is equal to accuracy. Do we have other metrics? Yes. For linear regression, for example, it is mean square error, MSE. What is the other thing that we could use? We could use precision if the data is not balanced. Like we have 10% of one label, 90% of the other. So instead of accuracy, we use precision. Okay. If there's just only one data scientist, would be the outcome of this. It justifies all the details, things that I'm saying. Hopefully we have one data scientist. Look at this one. What is the number of samples here? Anybody? 60,000. And what are the dimensions? 28 by 28. And that's why we are going to reshape it. What is the pixel value that we could have in every single neuron? It would show you a number between 0 to 255. Question: is it a good number for neural network? Neural network works the best with numbers between 0 to 1. They are going to see that in future because we use derivatives and so on. The numbers in a smaller range would be the most beneficial. That is why, look at this. We reshape it. We use reshape and we convert those 28 by 28 to 28 times 28, which is 784, right? And we divide that by 255 to make the number between the range of 0 to 1. Does that make sense, William? Okay, look at this. What is the range of the numbers that we have? 0 to 255. If you see any of these handwritten digits, there are lots of zeros here. I'm not gonna, lots of zeros. and imagine that you have written 4. It's going to be, for instance, 190 here, 200 here, 156, and in the edges that they are grayish, like less saturated black color here, you're going to have 90, for instance, and so on. So the numbers are between 0 to 255. What if we divide all these numbers by 255? So the range would be between 0 to 1, which is more convenient for deep learning. Does that make sense? So getting back here, this process of reshaping is one of the names, but bring them all into one column, like you hammer the picture, you make it one column. This process is called flattening or reshaping. Flattening, reshaping. This process that we divided by 255, which is the maximum number in the matrix, is called normalizing. So we did it manually. Is there any way that computer can take care of it by itself? Yes, maybe. Let's see. So everybody make sure that you have done, actually those who like to do. Just to let you know one thing, and maybe that's going to be interesting. I am that much idle and not busy that it happened that one person asked me, and that person was very much talented, hardworking, always present in the class, always on time present in the class. And she wanted to apply for a job at the other college. They didn't accept her because of, she looks like very much young. And whether you want to believe it or not, I went there, knocked the door, I said that I recommend this person. And they hired her. I didn't just provide kind of recommendation letter. I went there to make sure that she's going to find a job because she deserved it. And guys, I'm asking you, whenever you want to send to any prof that, would you provide any recommendation for me? Just think if you change your hats and if you want to recommend that person, are you going to put your signature to acknowledge that person? Why I'm saying this? Because that's the saddest moment when somebody send me email, say that, Reza, would you provide recommendation? And that's the saddest, because I'm very quick in responding and not responding to that person. Because I asked one of the team members and I loved the answer that he gave me. I said, what if I tell you that I come and visit you at 8 and I come and visit you at 9? What kind of friend would I be for you? And he looked at me and said that I'm not going to be friend with you if you come at 9. It's like, perfect answer. Perfect answer. So just think about that. If you are a manager, are you going to hire somebody who says that I'm going to be at 8 o'clock and shows up at 10? And coming to the work and doing everything except doing the thing that they should do? If you hire that person, awesome, guys. God bless you. This is a kind of model that we are going to do exactly in future. If you think that after finishing this, I start learning, I have never seen any exception. The model that we grow up, it's going to be the model that we treat. Going to this next part, we already answered all these parts, softmax I covered. I went all the way to this part, accuracy. Now's the time, 1:28. Let's have 10-minute break. We are going to start at 1:39 to make sure that we are going to have complete 10 minutes. quickly finish that and we are gonna start watching a video. Yes. Normalization, yes, sir. Lovely, that's it. Normalization, flattening, or reshaping, both of them are used. Right? Sorry?
The first column was moving to one. This other column.
This side is gonna be the first, the second column is gonna be the continuation, the third column is gonna be.
The other is
Uh-huh.
this other column.
Yeah, you're gonna see that. You're gonna see kind of video about all this, but good. I should buy your notes. What was the application that you said you used? Something note, perfect note or what? No, notability.
I'm in the wrong class.
Sorry,
I just realized I'm in the wrong class.
why?
I thought I had.
So you can just continue, don't worry, I'm gonna just consider your presence.
No, but, because I have a class right now.
Oh,
from
sorry,
1 to
so
thing, but yeah, I'm gonna be obviously back here on Friday. I thought we had one here on Tuesday, but I just got.
Friday, I don't have any class, I have just have class from 3 to 6 as well today.
This is 132, right? This one. Yeah, okay, I'm gonna have you again.
Okay, awesome, so see you then,
Yep.
take care.
It's like when you install external update. It's like any so it's limited to that.
But the problem is, if I use this as an extended marker, sometimes I forget to bring back to this one. And when I use this, when I use that, this system, when I use that as a double the because the resolution of this is 1,900 something, and the resolution of the other one is 3,200. It's gonna like half the quality. Do you have any S9's resolution? Because I checked Samsung and website. The first person.
That's why I'm going to say Samsung expert could ask me. You know more about it.
If there is Samsung section, then yeah. I probably next to last minute. Okay, so guys, if we want to say categorical, what is categorical? Look at this one. It says that from Keras utils import to categorical. just to show you what we had on the whiteboard, it was something like this, that we said, what is this one? It said that, hey, we are going to have a 0, 1, 2, 3, 4, all the way to 9. But the reality is, this is not going to be the best for deep learning. This format works, but it's not very deep learning friendly. So how could we change it to something that deep learning can relate to it like this? What is going to be the best way of representing numbers? This is what we call it two-categorical. Look at this. Instead of saying the output 0, 1, 2, all the way to 9, instead of saying it this way, we say if the number is 0, imagine that we have these columns, 0 all the way to 9. If it is 0, then just make the lamp of, Prakash, can you hear me? Awesome. Then change the lamp of 0 into 1, and the lamp of others is equal to 0. Does that make sense? How about 1? In that case, change the lamp of 1 equal to 1, and the rest would be zeros. The same for 2, 3, 4. This is what we call it two-categorical. Right? Okay. You might want to implement something. So apart from the code that you have in book, I provided a few more lines just to make it more understandable. Everybody, I'm sure that you ran this compile line. Let's just see what we have in the image number 0. If you run that, look at this one. You're going to have lots of zeros, and start showing some numbers like 18, 126. 126 is like in the middle. And then we have numbers. It's very, very black around here. So it's going to be 247. We have 250 somewhere I saw. Yeah. So these are the ranges that we have from 0 all the way to 250. And after that, let's have train images.reshape saying 28 by 28 is equal to 28 times 28. Then look at the result. This time you have one open bracket and you have one closed bracket. Before we had 2. It was like, let me just get back to here. Look at this one. We start with 2, so we have 2 dimensions, right? And we reshaped it into 1 dimension. We have just 1. That's reshaping. And yeah, we saw that. I just added these lines to make sure that it is clear for everybody and everybody can understand. The values, you remember it, they were before between 0 to 200 something. Now we divide them by 255, and the values, if you check now, would be between 0 to 1. You see that? Huh? And let's just go to the next. We are going to do the reshaping, the same thing that we did for the training, we are going to do for testing. We reshape that. We divide the testing part by 255 to normalizing. That's the word. And to categorical. This is the part that it says, hey, go and change. Let me, before getting to that categorical, let me show you what we have for train labels. I'm sorry. Train labels. What we have is like 5, 0, 4, and so on and so forth, all the way to 5, 6. These guys would be the indices 9,997, 98, and 99, right? Oh, sorry, 500, 9,000. Anyway, now after using categorical, what's gonna happen? Just let's use the same train labels. Do you see that? Instead of showing 5, we are going to have 0, 0. This is 0, 1, 2, 3, 4, 5 would be 1. But because it's like ellipses, you cannot see that. But for 0, it is obvious. For 0, the lamp of the first, which is 0, is on. Does that make sense? Remember this one? For 0, the lamp of 0 is 1. So that's why you see here. How about for 8? We have 8 and 9. Look at this one, the last one. The lamp for 8 is 1. For the rest would be 0. Does that make sense? Let's see what is the first. We do the same thing for the test labels as well. Everyone, let's try what is to categorical. I'm gonna run that y_train and to categorical. If I say y train and number of classes is equal to 6, why the number of classes is equal to 6? Anybody have any opinion? This is a bonus question. Huh? Where?
You are taking a
No, where do you say that we take? Why we didn't say from 0 to 12? Why we said 0 to?
because the number is basically between 0 to 5.
Awesome. Prakash, correct. Look at this one. Here, if I say change these guys to categorical, technically what happens is this one. For 1, the lamp of 0 is 0, the lamp of 1 is on, and the rest would be zeros as well. For the next one, 0, the lamp of 0 is 1, and the rest would be zeros. For this one, the lamp of 3, 0, 1, 2, 3 is on, and the rest would be zeros. That's what we call it to categorical. And when the output is something like this, it works the best for deep learning. By saying that, now it's the time. You remember apple and orange example? We said that, okay, these are the features, these are the labels. So let's just find pattern between them. What was the command that we used to find patterns? What was the method that we used for finding pattern between features and labels? It's in front of you. Yes, fit. And then these are the images, labels. Look, Pawan. What is this? Epoch. What is this one? The batch size. Look at this one. When I run this, did I run? Yeah. When I run this epoch number, it goes all the way. We have these number of batches in 60,000 these number of batches, every one of them. So it shows if I can pause it somewhere. My bad. Do you remember that it started from here? It went like this, and those numbers, they started getting better and better in terms of accuracy, and the loss started getting lower and lower, even in the first attempt. And the next attempt, you see, it's going to be a kind of drastic change compared to the first one. In the next one, it's going to be a bit better all the way to this. But it's for unseen data. What about it's for unseen? Sorry, it's for the data in hand. What about for unseen data? Test is for unseen data. If you can make a model that works perfect with data in hand, that's not that much useful. It is going to be useful when it can work the best with unseen data, right? So I'm going to run that, and it shows that the accuracy is 97. Guys, what is the difference between these two? It's almost 1%. What do we call that gap? Who said that? Okay, the gap between these two is called overfitting, and now you can see the accuracy that it shows. And by saying that, I quickly go through this to see if we missed any part. This is the only thing that says that the gap between training accuracy and the test accuracy is an example of overfitting. The question that we might have here is this one. Are we going to stop training when we see overfitting? Yes or no? Are we going to stop training when we see overfitting? Do you remember the validation that I said? We have training data, validation data, and we have testing data. As long as we see progress in validation data set, we keep going. The time that it's gonna start, instead of progress, we have regress, and then we're gonna stop it there. Okay, though. So if you just take a look at, please open the assignments number 1. Just take a moment, go through it for a second. Okay. Go through the steps, see what are the things that we need to do. And what do you see? Yaroslav, what do you see?
website layouts into an art form. Thanks. What's
Okay, don't you see that the steps that you need to go through are mostly the steps that you have already gone through? There's one thing, the best before starting the implementation is searching for fashion MNIST 36 minutes. This is the guy. Watch this one. It's going to help you a lot. The explanation. So before starting the assignment, please watch that. And I talked to some of the friends, asking them if the deadline is appropriate. It's not, it doesn't have any conflict with the other thing. So they confirmed that we have enough time. And so hopefully it's gonna work for you. So apart from this, we are going to watch together this one. Okay, sure. How about this? I'm going to.
Valley. I didn't imagine we have some.
I'm gonna do one thing. Control C.
Right. And we have
Loading your lab.
I'm gonna talk about that too. Yaroslav, please just eat it. Just finish it, please. Thank you. Let me just say what is the thingy? The name of this one is Fashion MNIST. And this is the link, Control S. So can you please confirm that you can, in course content, I've just sent that to course content. It could be the second file, right? No worries. And what is the group name? C#, no. This one, no. Data science.
Deep learning.
Oh, deep learning. Deep learning. I've already copied there. So in two places you have to. Okay. So let me just make sure that it's gonna.
Much needed update to the deep learning in Python with TensorFlow. What is going on, everybody, and welcome to a much needed update to the deep learning in Python with TensorFlow, as well as now Keras tutorial. It's been a bit over 2 years since I did just a basic deep learning video in Python. And since then, a lot has changed. It's now much simpler to both like get into it, but then also just to work with deep learning models. So if you want to get into the more nitty-gritty details and the lower level TensorFlow code, you can still check out the older video, but if you're just trying to get started with deep learning, that's not necessary anymore, because you have these nice high-level APIs like Keras that sit on top of TensorFlow and make it super, super simple. So anybody can follow along. If you don't know anything about deep learning, that's totally fine. We're going to do a quick run through of neural networks. Also, you're going to want Python 3.6, at least as of the release of this video. Hopefully very, very soon. TensorFlow will be supported on 3.7 and later versions of Python. It just happens to be the case right now. It isn't. I think it's something to do with the async changes. I'm not really sure. Anyways, let's get into it, starting with an overview of how neural networks just work. Right, to begin, we need to have some sort of balance between treating neural networks as a total black box that we just don't understand at all, and understanding every single detail to them. So I'm going to show you guys what I think is just the kind of bare essential to understanding what's going on. So a neural network is going to consist of the following things. Like, well, what's the goal of any machine learning model? Well, you've got some inputs, let's say x1, x2, x3. And you're just trying to map those inputs to some sort of output. Let's say that output is determining whether something is a dog or that something is a cat. So the output is going to be 2 neurons in this case. So just put 2 neurons. Now what we want to do is figure out how are we going to map to those things. We could use a single hidden layer. Let's say we're going to do some neurons here. And that's our first hidden layer. Now, what's going to happen is each of these x1, x2, and x3, these are going to map to that hidden layer. Each of the input data gets connected to each of the neurons in that first hidden layer. And each of those connections has its own unique weight. Now, from here, that first hidden layer could then map and connect to that output layer. The problem is if you did this, the relationship between x1 and dog or cat and all the other ones, those relationships would only be linear relationships. So if we're looking to map nonlinear relationships, which is probably going to be the case in a complex question, you need to have 2 or more. One hidden layer means you just have a neural network. 2 or more hidden layers means you have a quote-unquote deep neural network. So we'll add 1 more layer, and then we're going to fully connect that one too. And then once that's fully connected, again, all unique weights, each of those blue lines has a unique weight associated with it, and then that gets mapped to the output. And again, each blue line has a unique weight associated with it. So now what we're going to do is talk about what's happening on an individual neuron level. So again, that neuron has certain inputs coming to it. It might be the input layer X values, or it could be inputs coming from the other neurons. So we're again going to call the inputs X1, X2, and X3. But just keep in mind, this could actually not be, it might not be your input data, it might be data coming from another neuron. But regardless, that data is going to come in, and we're just going to get the sum of that data. So it's going to come in and be summed all together. But remember, we also have those weights. Each of the inputs has a unique weight that gets put, multiplied against the input data, and then we sum it together. Finally, and this is kind of where the artificial neural network comes into play, we have an activation function. And this activation function is kind of meant to simulate a neuron actually firing or not. So you can think of the activation function like on a graph. You got your X and your Y, and then a really basic activation function would be like a stepper function. So if X is greater than a certain value, boom, we step up and we have a value. So let's say here this is 0. Here.
Let me just pause here and tell you one thing. Guys, those activation functions that we use are gonna just cancel some of these neurons in the middle and emphasize on some of these. So technically, it's going to make this linear transition non-linear. And that's what we want. So if you just take out some of these neurons in the middle, it's not going to be ax plus b. It's not going to be linear.
Like, I guess, how applied?
Taking out neurons? Well, the thing is, we use ReLU. If the values are less than 0, just turn it off. And if the values are greater than, just use the same X. That's how we define X. Let me show you this. The definition of, it's something like the ReLU definition is like that. We say, if the values are less than 0, keep them 0. The value of X, if it is -2, -3. And for values greater than, just keep it as X, whatever it is. what happens if the content of that neuron is less than 0? We cancel it, we just turn it off. That's noise, that's not something that we want. We just pick those positive pulses, right? You might say that why this one works, what did we have before? There were two major, one of them was sigmoid that we had. The stir was the very initial one that didn't work well, so stir kind of things. So they just put that element there, and they saw that ReLU works better than sigmoid, so they started them just using that.
Yeah, this is our x-axis, 1, 2, 3. So if x, after being all the inputs are multiplied by the weights summed together, if that value is, let's say, greater than 3, well, then this activation function returns a 1. But today we tend to use more of a sigmoid activation function. So it's not going to be a 0 or 1. It's going to be some sort of value between 0 and 1. So instead, we might actually return like 0.79 or something like that. So coming back to this neural network here that we've been drawing, let's say here on this final output layer, you've got dog and cat. Well, this output layer is almost certain to have just a sigmoid activation function. And what it's going to say is maybe dog is a 0.79 and cat is a 0.21. These two values are going to add up to a perfect 1.0, but we're going to go with whatever the largest value is. So in this case, the neural network is, you could say, 79% confident that it's a dog, 21% confident it's a cat. We're going to take the argmax basically, and we're going to say, we think it's a dog. All right, now that we're all experts on the concepts of neural networks, let's go ahead and build one. You're going to need TensorFlow. So do a pip install -- upgrade TensorFlow. You should be on TensorFlow version 1.1 or greater. So one thing you can do is import TensorFlow, and then actually TensorFlow as TF, and then TF.version will give you your current version. So mine is 1.1. So now let's go ahead and get started. So the first thing we're going to do is import a data set. We're going to use this kind of the hello world example of data sets with machine learning. It is a data set that consists of 28 by 28.
There are a few things. As you see, the gentleman checked the version of TensorFlow. This is something that we shouldn't worry when we use Colab. I remember that some of the time, some of our team members said that Reza, mine doesn't work. It shows some errors because the version of the Python and the version of the TensorFlow, they were not compatible. The other thing is we use Keras, and Keras is already installed fully, and the packages are compatible. The other concern is almost for 90% of the time, you don't need to install anything. 95. And for those 5%, I didn't have any issue at all in terms of version compatibility.
Images, so it's like resolution. Images of handwritten digits 0 through 9. So it'll be like 0, 1, 2, 3, and so on. And it's a handwritten kind of unique image. So it's actually a picture, and we can graph it soon enough so you can see it's actually an image. And the idea is to feed through the pixel values to the neural network and then have the neural network output which number it actually thinks that image is. It's going to be challenging. I like the text you want to simplify and let you right. Grammarly makes your message clear so it's understood. So that's our data set. And now what we want to do is unpack that data set to training and testing variables. So this is a far more complex operation when it's actually a data set that you're kind of bringing in or that you built or whatever. For the sake of this tutorial, we'll use something real basic like MNIST. So we're going to unpack it to X train, Y train, and then we're going to do X test, Y test. And that's going to equal MNIST.load_data. So that's going to unpack it in.
So Keras, if I'm not mistaken, Keras already contains 8 different most popular data sets like MNIST, Fashion MNIST, Reuters, Boston Housing, IMDb, and a few more. And the good thing is it is already divided into 4 parts, 4 segments. One of them is the X train, Y train. So the dependent variables, independent variable, sorry, I mean the other way around. Independent variables, dependent variables, and the same thing for the tests. So when you just write that and press Shift Enter, it's going to just locate all those 4 segments into these portions respectively.
Now, just to show you guys what this is, we're going to use matplotlib. You can pin this or just look at it with me. We're going to import matplotlib.pyplot as a PLT. And what we're going to do is plt.imshow, and we're going to do x train, and we'll do the zeroth. So one thing we could do, just for the record, let me just print. So you can see what we're talking about here. So this is just going to be an array. It'll be a multi-dimensional array, which is all a tensor is, by the way. So this is your tensor, right? Okay, so that's the actual data that we're going to attempt to pass through our neural network. And just to show you, if we were to actually graph it and then do a plt.show, it's going to be the number, and you can just excuse the color. It's definitely black and white. It's a single color. It's a binary. So one thing we could say is the color map is equal to plt.color map binary, replot it. There you go. So it's not a colored image. So anyways, back to our actual code up here. Once we have the data, one thing we want to do is normalize that data. So again, if I print it out, you can see it's data that seems to vary from 0 to, looks like we have as high as 253, 0 to 255 for pixel data. So what we want to do is scale this data, or normalize it, but really what we're doing in this normalization is scaling it. So we're going to just redefine xtrain and xtest, but it's going to be tf.keras.utils.normalize, and we're going to pass xtrain. It'll be on axis 1, and then we're going to cut, paste, and we're going to do the exact same thing for xtest. And all this does, let's just run that, and then we'll run this again. And you can see how the files changed a little bit. It looks like it got a little lighter. And then
You see that?
down here, we can see values.
The numbers, the normalize that he used is exactly the same as what we did by dividing by 255. The good thing is you don't need to worry about anything. It's going to just calculate the maximum, find the maximum, and divide it by itself.
Are now scaled between 0 and 1. And that just makes it easier for a network to learn. We don't have to do this, but at the end of this, we probably won't have time, but if you want, comment those lines out and see how it affects the network. It's pretty significant. Okay, so the next thing we're going to do now is actually build the model. So the model itself is going to start as tf.keras.models. And then it's going to be the sequential type of model. There's 2 types of models. The sequential is your most common. It's a feed forward like the image improved. So we're going to use the sequential model, and then from here we can use this like model.add syntax. So the first layer is going to be the input layer, and now right now our images are 28 by 28 in this like multi-dimensional array. We don't want that. We want them to be just like flat. If we were doing like content or something like that, we might not want it to be flat. But in this case, we definitely want to flatten it. So we can use that. We can use like NumPy and the shape, or we can actually use one of the layers that's built into Keras, which is flatten. So, so we're going to do add, and what we're going to add is tf.keras.layers.flatten. So one of the reasons why you want this to actually be a layer type is like when you have a convolutional neural network, a lot of times at the end of the convolutional neural network, there'll be just like a densely connected layer. And so you need to flatten it before that layer. So it's used for more than the
What did we use instead of flattening? Reshape. Who said that? James? Oh, okay.
layer. We're just going to use it for the layer, just doing our lives easier. So once we've got that, that's what we're there. Now we want to do our hidden layers. Again, we're going to go with, I think, just 2 hidden layers. This isn't a complex problem. So again, we're gonna use the model.add syntax, and we're gonna add, and in fact, I think what I'm gonna do is just copy, paste, and then rather than a flattened layer, it's a dense layer. In the dense layer, we're gonna pass a couple of parameters here. So the first one's gonna be how many units in the layer. So we're gonna use 128 units or 128 neurons in the layer. Then we're gonna pass an activation function. This is like the function, like I said, like a stepper function or a sigmoid function. What is going to make that neuron fire or sort of fire or whatever. So we're going to use tf.nn.value for rectified linear. This is kind of the default go-to activation function. Just use it as your default, and then later you can tweak it, see if you can get better results, but it's a pretty good one to always fall back on. So we're going to add a second one just by copying and pasting. Again, I'm going to add a final one, and this is our output layer, which is still going to be a dense layer. It's not 128. Your output layer will always, if in the case of classification anyways, it'll have your number of classifications. In our case, that's 10. And the active
Oh, I think that a better term for it is number of classes, right?
activation function, we don't want it to be ReLU because we actually, this is like a probability distribution. So we want to use softmax for a probability distribution. So
What is the overall sum, overall number? William?
So that is our entire model. We're done with defining, the architecture, I guess, of our model. Now what we need to define is some parameters for the training of the model. So here, we're going to say model.compile, and then here we're going to pass the optimizer that we want to use. We're going to pass the loss metric.
What was the optimizer that we used a second ago? Ramsprop? But this one, let's see what's our.
We haven't really talked about it. Loss is the degree of error, basically. It's what you got wrong. So a neural network doesn't actually attempt to optimize for accuracy. It doesn't try to maximize the accuracy.
Do you see what he says? What he's saying is the neural net is not there to increase the accuracy. It's
Always trying to minimize loss. So the way that you calculate loss can make a huge impact because it's what's loss's relationship to your accuracy Okay, so the optimizer that we're going to use is going to be the atom optimizer. You could use something. This is basically this is like the most complex part of the entire neural network. So if you're familiar with gradient descent, you could pass something like stochastic gradient descent. But the atom optimizer, kind of like the rectified linear, is just kind of the default go-to optimizer. You can use others. There's lots of them. Not lots, but I don't know, 10 or so in Keras anyways. So anyways, there's other ones to go with. Atom seems to be the one that you should start with. For loss, again, there's many ways to calculate loss. Probably the most popular one is categorical cross entropy or some version of that. And in this case, we're going to use sparse. You could also use binary, like in the case of cats versus dogs, you could probably use binary in that case. But you could just kind of blanket categorical cross entropy everything. Anyways, then finally, what are the metrics we want to track as we go? And we're going to just do accuracy. Okay, so once we have all this, we're actually ready to train the model. So to train, it's just model.fit, and then you're going to pass what do you want to fit? So xtrain, xtest, I'm sorry, y. Okay, xtrain, ytrain, and then epoch3, total brain for it. Okay, let's go ahead and run that. And we should start to get some training. Hopefully it doesn't crash me on the recording.
look at this one. You remember in the previous one, it was like out of 200 something. When you don't say the epoch is what? Sorry, the batch is what? 60, the size of the overall is go till the end and then just calculate the things.
Okay, looks good. Let's zoom out just slightly so it looks a little better. And we can see actually our accuracy is already quite well. Our loss is also still dropping, so our accuracy should still be improving. And sure enough, it is. Right. And I'm not. Awesome. Okay, so we did pretty good. We got a 97% accuracy after only 3 epochs, which is pretty darn good. So once we have this, we can, this was in sample, so this is always gonna really excite you. But what's really important to remember is neural networks are great at fitting. The question is, did they overfit? So the idea or the hope is that your model actually generalized, right? It learned patterns and actual attributes to what makes an 8 and what makes a 4, rather than memorizing every single sample you pass. And you'd be surprised how easily a model can just memorize all the samples that you pass to do very well. So the next thing we want to always do is calculate the validation loss and the validation accuracy. And that is just model.evaluate, x test, y test. And then we'll go ahead and just print val loss and val accuracy. And we can see here the loss is almost 0.11 and the accuracy is at 96.5. So a little less than the one that we ended on, and the loss is quite a bit higher relatively, but you should expect that. You should expect your out of sample accuracy to be slightly lower and your loss to be slightly higher. What you definitely don't want to see is either too close or too much of a delta. If there's a huge delta, chances are you probably already have overfit. You want to kind of dial it back a little bit. So that's basically everything as far as the basics of Keras and all that.
Okay, so I'm going to, just to make sure you have everything for the review. And so now with this, take a look at the assignment once again quickly. And you see many of the things here that are already explained are the things that asked you to just do, right? So let's just go to deep learning, this one. Also, where is the, here it is. Okay. Although you have the link inside the assignment, just in case you want to. By saying that, if we get back to the yes. We get to this part that says data representation. It says that everything that we have in Keras and using inside deep learning, all the data that we have, we call them tensor. And what is tensor? It's just a trait that you carry the values inside. If it is just one value without any dimension, it's a scalar. So you see, it says that we started from data stored in multi-dimensional NumPy arrays, also called tensor. So at its core, a tensor is a container, is a tray that contains data. A container for the data. And one of the confusing thing is here, it says that a dimension is often called an axis. But look at this one. Here, if you say another a tensor that contains only one is called a scalar, yes. The best way to call the dimensions of tensor is rank. It's not confusing at all. If you want to find a proper name, that is rank. The number of axes of a tensor is also called rank. What is this number? 12. Is it an array? Is it a matrix? No, it's just one scalar. That is why if we say how many dimensions does it have? 0. But if you have a vector, that's the confusing part. A vector could have several items like 12, 3, 6, 14. This is typo. It should be vector with 4 tensor. So that is why it called it 4-dimensional vector. It should be, or you should add 1 number to the vector. This is confusing. So what is the dimension here? Based on the tensor, we have just 1 dimension. That is why I said, let's use rank for it. So we have just 1 dimension, 1 axis. In the lower part, it mentioned that the rank of a tensor being the number of axes. Like what? If you have 2 dimension, an Excel sheet, how many dimensions you could have? An Excel sheet, guys, it's not a trick question. Definitely, guys, you have rows and columns, right? You have rows and columns, so 2 dimension. I'm telling you, I'm not asking you any trick question. Very simple. What are the samples that you can say for the other name for tensor that has 2 dimension is matrix. No doubt many of you are gonna just be in this field sooner or later. And I'm just gonna imagining the time that you're saying, Reza said those things, and I was just buying things in Amazon. Okay, look at this. Here we have a matrix. What is one of the most famous things that we can have? 2-dimensional things. Like you have the stock Excel sheet, Apple, Microsoft, the value of a stock in the market, right? So the rows are the name of the companies, and the columns could be the stock value in 8 o'clock, at 8 o'clock in the morning, 9, 10, all the way to 5 p.m., something like that, right? So this is what? A two-dimensional or a matrix, rows, columns. But is it useful just you keep today's Excel sheet just for 1 day? So you want to see if it goes up or if it goes down, and if you want to invest. So you need to have for today, tomorrow, and things like that. In that case, what do we call it? It's gonna be a time series. Am I right? Wrong class. Right? So if you have it for today, tomorrow, so you have another dimension, 3 dimension, right? What is the 3rd dimension? Time. Okay, if you want to see the rank of a tensor, one of the quick way to find that is, one of the shortcuts is just count the number of square brackets or brackets. Here we have 3, so the dimension would be 3. And it says x.ndim number of dimensions like that. The other thing is the key attributes that we have. One is rank, the number of dimensions. The other one is shape. If we have 3 rows, 5 columns, so it's gonna be 3, 5. But if we have 3, 5, what do you understand from this? Yes, 3 rows, 5 columns, but what is the first 3?
It's 3 of those.
Lovely, number of samples. Always. The first number, you remember, we started with 60,028 by 28. So 60,000 pictures. the first number is always number of samples. Good job, William. Look at this one. What about the data type? One of the things that I always show when I do the calculations, that it is like this when we deal with tensors. Why? Because it keeps the type. If it is integer, if it is float, but not string. Why not a string? William, how many characters we have in your name? 7. Reza, 4. Right? Stefan, how many characters do we have? Okay, so we see that they are not equal. So we have variety of strings of, and the whole idea of having tensors is, note that the string tensors do not exist in NumPy. Why? Because tensors live in pre-allocated contiguous memory segments, means that we know this is integer, the next integer, the next integer. To say that a string, how many characters? It's not known, right? That's why we cannot use it for tensor. And let's get back to the example that we had in the previous semester. You remember I said, scikit-learn is not happy to work with the strings. The reason. Okay, so it says that from keras.datasets import mnist. This is something that we started our session with. And then everybody, please take a moment and run these lines. Yeah, we talked about when we have just scalar 12, no dimension. When we have a vector, the dimension is 1, number of elements is 4 in that example. When we have 2 dimensions, when we have 3 dimensions, and then we just, this is the part that we started together again, mnist, then we print, what is the number of dimensions in mnist? We have 3, number of samples, 28 by 28. The other thing is, how about the type that we have? You remember the numbers were between 0 to 255. And if you divide it by 255, it's going to be between 0 and 1. So it's not going to be unsigned integer anymore. What if I just want to see sample number 5, index number 4? So 0, 1, 2, 3, 4, 5. Yeah, 0, sorry, 4. If I want to see what do we have there, look, it's going to show you lots of zeros and ones. And based on what we learned in the, and actually we have it in book 2. So if you just use matplotlib.pyplot and then say image show, im show, the thing is we have color map equal to plot.colormap.binary, black and white. And you see we have a kind of shadow of different, well, it's not purely black here, so they are. If you say what is the label for that, definitely it's going to show you, sorry, it's going to show you 9. Is it possible to slice? That's the next part and the last part that we are going to cover today. Is it possible to slice? What can you understand from this? Anyway. Guys, the bad thing about this kind of thing is, if I give you a sample, or if I say in the textbook, in the mnist that we had, then the train image, this is going to show fill in the blank. Guys, even ChatGPT cannot help you. So please just pay attention to this part. What is the first dimension? Yes, Pargash.
And basically you're getting a 90 values and you are out of, I don't remember the 6,000.
60,000.
You are just taking this from 10 to 200. So starting from 10.
Excellent. The first dimension is what? Samples. You remember? I said, write it somewhere. The first dimension is always samples. And as Prakash said, it's going to be first, well, from 10 to 90. Awesome. This is exactly the same as this one, but I prefer this notation because it's more readable. Or you can say, hey, from 0 to 28, 0 to 28. If you don't mention this, it means that everything from the beginning till the end. Okay. Now, if you just say print the shape, it's going to tell you we have 90. Let me just run it. We have 90, 28 by 28. Yes, as you can see there. We have 90, 28 by 28. Now, what does this one mean? All the samples means that's 90, right? You see, just you nudge your head, Prakash, and you get bonus mark. Yeah, workout. No, you have to use a correct direction. It was this, you did this. Yeah, next time, don't worry. Look, here's gonna be all the samples of the train images, not a slice of it. So it's gonna be 60,000. And what does it mean when we say 40 to the end? Okay, tell me, I have, let's go to the whiteboard. It was here. So if I bring, my Paul. If I have this picture, a screenshot. Okay, tell me, what is the section that shows if I say 0 to 14? I don't know, and I want you please to discover, is 0 stays here? And if I say 0 to 14, it's gonna be this and this. I don't know. Actually, I didn't have time to discover that. So please find it. We have 4 possibility. This one, this one, this one, and this one. Which top left, top right? Where's the 0, 0? That's the most important. If you just say the coordination, that would be awesome. Top left, top right, bottom left, bottom right. Okay, because I don't know, one of the things that I can do is simple. Say 20 and 20, right? See which part is going to be more visible. Look at this one. Oopsie, where did I? I'm sorry. It was Control Z. It was 14 all the way to the end. Sorry. And if I say, how about this? If I say 0 to 20 and 0 to 20, what's going to happen? Or I can just simply say to 20. What's going to happen? Guys, can you get that? So technically 0 stays here on top left, as William said. So how about this one? What's going to be the output of this, William? Yes, 0 to 16. Do you see it just does all the process on 60,000 in winkle of an eye, just in less than a second. And now there's 4. If I just say, hey, show me. This one means everything, all the rows means 28 pixels. But this one means from the beginning all the way to 16. So, right? And then the other one is, what if I say, I played around with all these numbers and then I showed the color. What is this one? 7 to -7, right? So start from 7, -1, -2, guys. It's like this. When we say 7, it means that start from 0, 1, 2, 3, 4, 5, 6, 7. And what is -7? So it's going to be -1, -2, -3, all the way to -7. So it's going to just give you this center. It's like zooming. Does that make sense? So let me just, because we are recording, let me just show on the whiteboard again. It means that I start from 0, 1, 2, 3, 4, 5, 6, 7. It's going to be here. It's going to be 0, 1, 2, 3, 4, 5, 6, 7. So the intersection of that, it's going to be this point. And it's not exact because, and the thing is, -1, -2, -3, all the way to -7. And -1, -2, all the way to -7. So it's going to be something like that. So it's going to be this portion. Does that make sense? Well, actually, it's like magnifying that. Okay. So by saying that, let's just see which part. Yeah. We covered everything that we designed for today. You are going to have right after 6 o'clock, Stefan, you asked me, you're going to have the code, the collab all the way to the end of this picture. And it's a funny thing. Before I needed to go and just do this, and one at a time, I delete all those things. If you want to just slice your collab, that's a trick. Say text from here, run, collapse everything, just drag and drop. It's gonna just be as simple as that. Delete that one. Done. Okay. Just quickly, I'm gonna take care of the attendance. Meanwhile, my suggestion with your friend, just go and review the assignments. I need to take care of the attendance. Downgraded, but not in. Or hold on. So just you can add yourself to the class. So to just ask a question. Enroll in the classes. You have to first check the class. It should have. Wait, wait after the. I'm gonna, you're the only person who couldn't like do nothing about it, but let's see, maybe. We have two places for that too. One of them is in the submission folder, one of them is in course contents. Just download, right, click on the right side, look. There is download option. Do you have any?
I downloaded the.
Thank you. Sorry. Okay, I'm going this, there is an, identifier, that's the primary. Right. Okay, go to the, assignments folder as well. Forty. I remember the test. Thank you, 42. So, good. Awesome. So can you open Prakash inside the Simon folder? Can you open that one? No, I'm talking about total assignment submission folder. There are 2 files over there. Please find that. Sorry, that one. Keep with that. Awesome. Line or the right access to the one page and make sure that it's the kind of final version. It was so now it's so make the number between 0 to 1 because that's what learning the work rate, changing the coefficients and so on. You're going to calculate it directly. But if the number is small, it's easy to add. They're going to get there in 2 yeah, you know it there. Sorry. Those who had issue and wanted to fix the issue like Nicholas, yeah, have a good one. Yeah. I'm gonna stay to fix. Have a good one. Take care.
Stuff we did today on.
Sorry, I'm gonna
Yeah.
post it in the course content and in the.
Working.
Sorry?
I want to see what I did wrong.
Okay, I will. After finishing this class,
Yes.
I'm gonna just, yeah, have a good one. Take care, take care. What do we call it? Deep learning. Okay, I'm gonna just give me a second. My apologies. I've forgotten to just stop recording. So stop sharing and stop recording. Where is it? Stop. Have a good one. Take care. Ciao, guys. Bye.
Hope I'm in your good books.
Sorry,
Am I in your good books? Am I in your good books?
you're always.
Always?
Yes, you're in
Good to
the.
know.
Yeah, good to know that you're always okay. So I'm sorry. Have a good one. Sorry. Let me just.
Have a good one.
You as well. Take care of yourself. Sorry. Stop recording. Where is the recording? Stop recording.